Then I want to ask one more question on the top-up system, and it kind of leads us also to the next thought. What what is the purpose? What is the purpose of this air gap here?
Uh, None whatsoever. However,
Mhm.
there's some been quite misleading regulatory regulatory advisory texts written in Australia saying there needed to be an air gap there, so the stormwater um, can't somehow magically jump up from the street into the tank. As you can see, that's impossible.
Mhm.
How on earth can that happen? So welcome to my industry. Um, However, the other issue is if you have a trickle top-up system and it gets jammed, it could keep topping up with mains water and continue to overflow if the
Mm.
float is jammed. So
Mhm.
you can
So
actually,
if this valve gets stuck open or something like that,
yeah, you can see
yeah,
the
it would
continual
continue.
overflow from your tank.
Mhm.
That would be a more sensible reason for that. Unfortunately, as we've discussed, trying to interpret regulatory documents throughout this course,
Mhm.
the other less credible explanation has turned up in a number of regulatory documents that it's to stop backflow from stormwater systems. And you can even see from that diagram uh, such a concept is impossible.
Right. Well, if you do it, you're going to want to put a good screen on there to prevent anything from getting back into your tank.
Well,
Let's talk a little bit more about backflow then, because it is something that comes up a lot, um, and and especially if you are in an urban area or not, and need to get a plumbing inspector in to look at your system, your dual system. This is probably one area that the inspector is going to be very diligent on, or interested in, or make some comments about. Correct?
yeah, and it's backflow is all plumbing inspectors love to talk about backflow, particularly if they've been trained or work for a water utility. It has been used in our country, and it's a failed excuse now as a reason not to have rainwater harvesting in urban areas. Um, Heated argument in this country about, well, it's water monopolies protecting their monopoly supply. Um, we've sort of got through that. Backflow has been confused with, the genuine risks of, say, a paint factory or a chemical manufacturing company or a morgue or something like that that has a genuinely harmful fluids that are stored that may somehow cross cross connect with a mains water supply because they're also using mains water makeup water for different purposes. So these are genuine backflow issues. The thinking around that um, in the late 90s in Australia at least started being applied to the emerging urban rainwater industry. To date, there's been no recorded example of backflow of rainwater harvesting in an urban area into a mains water system, and there's certainly been no um, known or proven case that backflow from a rainwater harvesting system has actually created any harm in an urban area or an urban water system. So
Mm-hmm.
there's a lot of rhetoric, but it just hasn't happened. So, however, your water utility will be concerned, and your health department potentially will be concerned that they don't want water flowing from private properties back into their water distribution system.
Mm-hmm.
As we talked about earlier on, if you have a water meter at your property boundary, um,
Which you will almost certainly, unless you're on well water, but you
so
will.
so water meter at the interface between your utility supply, which they use for billing, and your house. A very interesting thing: these meters don't flow backwards. So
Right.
even the water meter that's at your property boundary, where the mains water comes into your property, utility water, it can't flow backwards. It's actually usually a dual check valve standard. Um,
Yeah, because then your meter would flow backwards and you wouldn't have to pay.
um,
The water went back the other
so,
way.
thank you, Michelle. That's the argument we use to unpack all these misconceptions. So
Uh-huh.
first of all, if you've got a dual water supply system, you've got a water meter on your property boundary.
Yeah.
It can only flow
Oh,
into the system, not backwards.
I'm going
So
the wrong
the
place.
water meter is protecting you at the property boundary.
It's there.
Yeah,
There
there,
we go.
that point.
Yeah.
Um, However, and if you've got one of these bypass systems, the actual switching device or bypass valve arrangement is also a dual check valve equivalent non-return valve. Um,
Mm-hmm.
and you know, if your pump's not operating, it's very difficult for water to flow through it. So without even putting in an additional check valve that many plumbing standards claim you need, your normal bypass system, mains water bypass system in an urban area has actually triple barrier protection
Mm.
from bypass. And
Right.
it's worth explaining that to your plumbing inspector when, if you have this argument. So, which you probably
Mm-hmm.
will. So,
Yeah, you probably will. The story I want you to bring up, Peter, was a conversation we had earlier around the scenario where the mains water might actually be at a lower pressure than your rainwater harvesting system, because I thought that was really a poignant, a good point.
yes, we did discuss this in one of our webinars, I think, Michelle.
Mm-hmm.
It's a scenario we thought through. So we explained all this, and some of our health departments and water utilities came back to us and said, "Oh, but no, no, no. There'll be situations where the mains water will flow in the opposite direction, so it will be flowing away from the house. It'll be suction rather than pressure,
Mm-hmm.
and therefore there's a chance to draw some of the rainwater through the system."
Mm-hmm.
Um,
Back
so
into the
let's talk
mains.
about this for a little moment before we get
Yeah.
into whether or not this is probable or credible. For that to happen, your three systems that can't flow backwards have to actually leak and flow backwards. Okay, so there's uh, the water meter at the property boundary, the pump, and the bypass valve all have to fail.
Right.
So um, fairly improbable. We actually did a really conservative risk analysis on it. Those three things failing together to allow some water, which would only be a trickle, teaspoons full anyway. But let's just step our way through it. The probability of those three failing together, even in the worst case, um, is well over 1 in 1 million. So it's a very low number. So just say that did happen.
Mm-hmm.
Why would you have suction in the water distribution system? It's because you have a mains break.
Mm-hmm.
So a small volume of water is flowing through your potentially failed three devices in your home.
Yeah.
So say it got drawn into the system, there's only
Mm-hmm.
suction in the system because you have a mains break. So what happens when you've got a mains break?
All the water from the groundwater and your storm water is probably getting into your mains as well.
And there's soil and all sorts of other things in that main. So that
Right.
the whatever quality of a small amount of rainwater that, in the unlikely event that it's drawn into your system, will be nothing compared to the water quality created by a mains break. However,
Right.
there's also, so we were talking, highly improbable events here. But this played out over a period of time. We actually wrote a paper on it and drew a risk tree. Just say all that did happen, and for some reason, some water got drawn into someone else's house. You've got a large volume of mains water and a tiny volume of rainwater in the system. So rainwater systems aren't very contaminated, if at all. So it's highly diluted potential unlikely contamination in your mains water system. Then it has to be drawn into someone else's house in the mains water system, and then they have to drink it in sufficient volume to be potentially at risk. And then there has to be an infectious dose or a harmful dose of some contaminant in that sufficient volume of water that person has drunk. And then their immune systems have to be not functioning that well enough to resist that. There are so many probabilities and so many things have to go wrong in sequence for something harmful to happen. The risk was 1.25 times 10 to the power of 26. So 1 to an almost infinitely small number. So given that our health standards in water distribution systems are about 1 in 50 chance, when you think of the way the standards are constructed, and at best 1 in 1,000 chance, which is hardly ever enforced, the potential risk of backflow creating harm, that's why there's been no recorded harm that we know about, is so tiny it just doesn't compare to the actual real risk within the utility water system.
Well, that was a fun exercise thinking that through. But I don't doubt that bypass and getting bypass systems approved, this may still be a challenge for our students.
They will be a challenge. There are long-held views. All that work we did with the health departments is something that we're still finding time to get in the international journals rather than just in the briefing documents for health departments and so on. So the whole international industry sees this logic. So the regulatory conversation with your local authority and your plumbing inspector, or what type of inspector they send to your system, around this type of system is always interesting because of all the preconceived ideas.
So it's just best to be informed, right? Understand these principles and ask simple questions. Ask good, simple questions, and you might be surprised. It might be a lot easier.
And make these simple propositions that we have presented in this lesson and elsewhere, and see how the inspector responds.
Okay. Thanks, Peter.